Excellent, I love that color. All right, so 22.b, reciprocal functions, I think is where I need to pick up today, if I remember correctly. Reciprocal function. What does reciprocal mean?
Reciprocating.
Opposite in what sense?
Switch.
Opposite sign.
Switched in what sense?
No.
No, it's
Yes.
not. That's negative.
It's when you flip it. The reciprocal is it's the flipping reciprocal function, okay? All right, so let's take a simple example here of the function y equals x. What does the graph look like?
Just 2 equals 2.
Not
It's a
quite.
one-to-one linear function.
That's right. But it is. It is a one-to-one linear function. How very erudite of you. Okay. The graph looks like this.
Why?
Equals
Because
x.
everything you put in is going to be the same thing.
That
So,
makes so much sense.
0, 0. When you go 1 on the x, you go 1 on the y. You go 2 on the x, you go 2 on the y.
Wow.
Why can't you do it the other way?
What other way?
Like this
I
way.
can't find it.
That's incredible.
Because if I go negative 1 on the x function, if I went up 1, that would be negative x and an x of negative 1 and a y of positive 1.
Okay, got it.
It's fine.
That would be y equals negative x. Let's keep it simple here. Y equals x. So the question is, what do we do when we want to change color?
Run.
Green.
Let's change colors, and the reciprocal of this would be y equals 1 over x. So, there are a couple key factors to keep in mind here. One is, let's do something else.
Purple. You see while the show what we're doing, and I'm like, and then up same color.
Alright, some key factors here. There's going to be, excuse me, there's going to be some common points. Usually centered around number 1. Ones, sure. So in this case here, when x is 1, what's y? 1. When x is 1, y is 1. Really? When x is 1, y is 1. So this point right here has an x. When x is 1, y is also 1. Now, what about on this equation? When x is 1, what's y? Also 1. So this point right here is on both graphs. What about negative 1?
Wait, how is, I'm losing you with that second one, y equals 1 over x? Why would y equal 1 if, what? I don't understand. Sorry.
What is this?
I hated these. The
When
weird.
y, if I plug in a 1 for the x in this equation, what's y?
1.
1. In this equation here,
Oh, the equation, both of them are
if
connected.
I plug in a 1 for x in this equation, then this y also becomes 1.
Okay.
So that's this point right here.
Purple. Why do I always say
Green.
that?
I just said two colors I've already been used.
Okay. Now what about, now the other one to look for is negative 1. In this equation over here, if x is negative 1, what's y?
Negative 1.
Boy, that was tough. If we go left 1, we go down 1, and this point right here is negative 1, negative 1. What about in the red equation over here? I
Negative.
need a new red marker, don't I? If I plug in a negative 1 for x, what's y? Negative 1. Hey, what do you know? So these 2 points are common to both equations. So that's one thing to look for.
Oh, I don't like these.
The other major thing to look for is with reciprocals. And before I write this down, all right, I'm gonna have to pick a color here. Let's go with pink. No, let's go with black.
To be politically correct.
Okay. In this equation over here, what happens if I plug in a 0 for x? What's y?
0.
0. Well, that was pretty tough, wasn't it? So that would be this point right here. in the red equation, I need a new red marker, huh?
You need a new marker.
Use the
pen.
pink.
All right, what if I plug in a 0 for an x in this equation?
Undefined.
Zero.
Oh, what?
Is it 0?
Undefined.
Why?
Because you don't know how many zeros.
1 divided by 0,
Is 0.
anytime you divide by 0, it's undefined.
You don't know how many ones you can go into zero.
So, the other key concept here then is that whereas when x is 0 on this equation, y is 0, but when x is 0 on this one, y is undefined. And what we do there is we put an asymptote here because there is no value for the reciprocal function at 0, at x equals 0. So the way to say that, or the key, or the idea here, is that zeros and asymptotes trade places.
What's an asymptote?
One of these dotted lines where the function does not exist.
Asymptotes. There we go.
And need a new red. Red.
Red.
The white wood. Incidentally.
Figured I better stock up.
I like the white wood.
Just get
Okay.
the Christmas gifts.
Let's fill it. Ooh, look at that. It's pretty.
It's like Christmas.
I can see now.
We should just write red
The
and
rain
green.
is gone. Okay.
Red and green for the rest of the year.
No.
No.
Yeah.
Okay, so zeros and asymptotes trade places. Now, there's one other thing that happens with these, and what happens I used? Pink
Pink.
and orange.
Purple.
That should work.
Purple.
Pink.
Purple.
In this function here, what happened? Let's focus on the reciprocal. I'm just going to copy the equation down here. In this here, as x gets smaller and smaller. Sorry, let's go the other direction first. As x gets bigger and bigger, what happens to y?
Small.
Don't know.
Smaller.
As x gets bigger and bigger, we put a larger, a 2, and then a 4, and a 10, or 100, or 1,000. As x gets bigger, what happens to y? Y
Bigger.
gets smaller and smaller.
Because the fraction's small.
Because the fraction is smaller. The larger the denominator, the smaller the fraction. So what happens is, as x gets smaller,
Get a weird bow tie looking thing.
as x gets smaller, what was I saying? As x gets bigger, the fraction gets smaller.
Please connect charger.
Oh dear.
Okay.
Uh-oh.
But it's still it's still videotaping.
Excellent.
So
Hang on.
I'll give it some chance to look at that.
He takes his job seriously.
It is
I'll-
handy to have USB extensions with these things.
You know, I wanted to be a cameraman for National Geographic once.
His monotone voice.
There we go.
You know?
Okay.
I'm working on my mountain man imitation.
All right. So as x, okay, excuse me. As x gets larger, remember this is the x-axis over here. X-axis, y-axis. As x gets larger, as we go out this way with larger and larger numbers of x, y gets smaller and smaller. So we know this point is on the graph, and we know that y is going to get smaller and smaller and smaller and smaller and smaller as we go.
But X
Same thing's going to happen in the negative direction. As x becomes a larger and larger negative number, y is a smaller and smaller negative fraction. And I'll just tell you that it keeps going that way. It never actually gets to 0 because it doesn't matter how big you make the denominator, y will never be 0. So it'll just keep getting closer and closer and closer to the x-axis, but it'll never actually touch it. Same thing in that direction.
How is that possible? If it gets closer and closer and closer and closer.
but never touches it.
Yeah. Is it kind of like the half?
What value of x can I plug in to make y equals 0?
0.
No, that's undefined.
Exactly.
That's a change.
Infinity sign?
No, even still, that would just be an infinitesimally small fraction.
Right.
Joe,
Okay.
you do realize you're sitting right next to the camcorder that has a microphone? Yes, I know. It's rather distracting. Okay, let's go the other direction now. Right. Let's take our same function here. What happens as? Nope, I used pink. What else was left? Orange.
Orange.
Now let's go the opposite direction. As x gets smaller and smaller, so as x gets smaller and smaller, closer to 0, as the denominator gets smaller, what happens to the numerator? Or what
Bigger.
happens to the fraction?
Bigger.
It gets bigger and bigger.
Wait, so could you put a fraction into there?
Sure.
Oh no.
Let's say x is 1/2. What's 1 divided by 1/2?
2.
2. What's 1 divided by 1/4?
4.
What's 1 divided by 1/10?
8.
8? It is it. No.
And yes, this is the brainiac class. Okay. So as excuse me, as x gets smaller than 1, the fraction gets larger and larger. And it goes up like this. And the same thing happens in the negative direction. When x is negative but still gets smaller and smaller closer to 1, it's going to get to be a larger and larger negative number. So the characteristics of the reciprocal function is you look for, especially when you need to graph these, you look for common points, the points that they have in common, and that's usually 1, 1, and -1, -1. And where the original function crosses the x-axis, where the original function is 0, the reciprocal is going to have an asymptote. And then the other thing is, how do we describe this? As x gets bigger, y gets smaller. What should we say about that? Maybe help me out here. There's 12 of you.
What are you trying to say?
That this one gets where one gets bigger, the other one gets smaller. Where the other one gets smaller, where one gets smaller, the other one gets bigger.
Big goes small and small.
What?
Reversing
Decrease.
Call
it degrading.
X increase, Y decrease. X decrease, Y
You should call it degrading.
Let's see. How about inverse?
values. Inverse increase.
I'll just say inverse increasing and decreasing. Okay, so
Training.
there's 1, 2, 3 things to look for when graphing these.
3 thing.
So,
Common points.
Good job, Dwight.
Look for ones. Zeros,
Good.
that's
Oh,
on our
oh,
formula.
It is. I should also mention it's also handy to draw a little table of values. And okay, free for all. Hello.
On a boat.
Job,
It's also handy to do a table of values. Table of values. This will help sketch the graph. We're not looking for exact masterpieces here, but what we can do is say
Exact pieces.
in the original Brown function here of y equals x, if we set up a table of x, y values, let's do -2, -1, 0. You don't have to do this many normally. I just want to show you what it looks like, or what happens. When x is in the original function, that's an x. When x is -2, what's y?
-2. -2.
-2.
Oh, what
In the original function, when x is -1, y is?
-1.
0, 1, 2.
Boy, you guys are smart. Okay, so now on the other function, the reciprocal function, red. in the red function, y equals 1 over x. Table of values for this one. Let's do the same thing. -2, -1, 0, 1, 2. What's y when x is -2?
Negative 1/2.
-1/2.
Negative 1.
-1.
0.
Undefined.
Undefined.
Sorry.
Whole 1.
1,
1/2.
1/2.
You'll not, you won't be able. You can see my heartbeat on this
Nice.
You can see your heartbeat.
So we
Yeah.
know you're helping.
because the camera's
Wait,
here.
I'm confused,
Yep,
Mr. Good.
When I
How
was
do
dealing
we
with 1
know
because right here
all
it's
those
white.
things?
Just plugging, if I plug in a -2 for x,
Oh,
what's y?
okay.
That's all that is. And what that does, that helps us put some points on the graph so that on the our reciprocal function, when x is -2, so over here, y is -1/2. So, this point is on the graph. When x is -1, y is -1, so I already have a green point, a point there. And when x is 0, y is undefined. That's why there's an asymptote here. There's no dot there. When x is 1, y is 1. We already have that there. When x is 2, y is 1/2. So that's about there. It just helps us put in some additional points.
Could you use this to figure out? Let's say maybe totally hypothetically, you're making a headboard or something like that, and you want it to curve up and then have something like that and then curve down. Could you use this type of math to figure out how the curve angle?
Sure.
You could?
I guess.
Really?
I'm not sure exactly how you would use that, but
No, I mean because there are curves there, Ooh,
yeah, there are lots of different types of curves. I would suggest you not try to make that connection because
Okay.
that might hurt your brain
Okay.
and waste your time. Okay.
Because
Purple.
I said orange first.
that wasn't actually hypothetical. That's what me and my mom did, and we just eyeballed it because I couldn't remember the math.
That didn't happen.
What was in it?
Can I take a picture of
It
this?
was Drew's fault.
Mr. Reed.
I used the force.
No, it was JJ. It was all JJ's fault.
Well, if you want to
Wait,
picture
can I
this
just
as it
take a
is,
picture? Or are you putting it on the website?
I was going to do one more example. Go ahead and stop the video for now.
Is there
Bye
stuff
bye.
we should put on our phone